Hello, welcome to everyone in this video. This is the part 2 of the solution of mechanics for this that is the CC2 paper for semester 1 of physics honors under University of Calcutta. This is the part 2 of the question of this year 2021. In part 1 we discuss question number 1. At the first you can see the total question paper. This is question number 1 which already discussed in part 1, and this is question number 2, 3 and 4 that wants to discussed that will be discussed in this lecture, and after that in the upcoming lecture we want to discuss question number 5, 6 and 7. That's it, right? So I request all of you try to solve this question at your choice, and after that continue this video to watch the solution. Question number 2, which says the force on a particle is given by this. This is the force which is Cx j cap, where C is positive constant. The particle moves in the xy plane counterclockwise, that is anti-clockwise direction, around a square loop whose corners are 0, 0, L, comma 0, L, comma L, 0, comma L, right? Calculate the work done on the particle by force during the complete trip around the square. When a particle complete this square, what will be the work done? Okay, so for that we can break into four part. For this part 1, the work done will be this one, and you can see if you dot with this F vector with the dx, that is along the I cap, so j dot I, which is 0, so work done for this portion will be 0. For second portion this will be j cap 1, and the x at that point is L. So if you put this value x equal to L, and the integration will be 0 to L along the y, so it will be G L square, right? So work done for this part 2, this is CL square. Next in the for part 3, this will be f dot dx, and here also you can see the f along j direction and x displacement along I direction, which are perpendicular to each other, so work done will be 0. And the fourth part you can see there x is 0, here the x value is 0, so if you put the value of x is 0, you will be obtain this j dot j1, but x is 0, so that's why this is 0. So you can see work done for part 1, part 3 and part 4 are 0. Only for part 2 there is an work done CL square. So for a complete loop, which is a closed loop, you can see this is a closed loop, and the work done for this closed loop is not equals to 0, since the work done of force, or since the work done for a complete loop is not equals to 0. That's why we can say the force is non-conservative. If the force is conservative, then the work done for a closed loop must be 0. But here you can see the work done for a closed loop is not equal to 0. That's why this is work done. That's why this is non-conservative force. Go to the next question. Next question says a particle of mass 2/3 kg is subject to a potential energy, this one, where x greater than equal to 0 and expressed in meter. What is the maximum value of the potential energy? Next, if the particle is released at x equal to 4/3, find its velocity when it reaches x equal to 3/2. So the given potential energy function, this is the given energy potential function, and at maximum value, you know, the first derivative is equal to 0 and second derivative is less than 0. Now you can find the first derivative of this potential function, that is 6x minus 6x square, and second derivative will be 6 minus 12x. Now the first derivative at the maximum, this equals to 0, so finally you will obtain the value of x is 0 or 1, and second derivative equal to this one. So if you put the second value of x equal to 0 in the second derivative, you will be obtain 6, which is greater than 0, so this is not a minimum value. So there's x equal to 0 having the minimum value, and for x equal to 1 this is negative, so this gives you maximum value. So if you wants to find out the Bmax at x equal to 1, this will gives you like that. So just put this value x equal to 1 in this format. So you will obtain this maximum energy is 1 joule. Go to the next one. Next question says sorry, next part says, if the particle released from x equal to 4 by 3, find the velocity it reaches x equal to 3 by 2. So particle reaches at x equal to 4 by 3, velocity is v1 at released, that means initial velocity is 0, and at this one velocity v. So from kinetic energy from total energy conservation, kinetic energy plus potential energy at that point equals to kinetic energy and potential energy at that point. So there is a expression for potential energy. Put this value of x, you will be get the potential energy value for both side. And here the kinetic energy of initial is 0 and final kinetic energy velocity is v. So from here you can easily find out the value of velocity, that is plus minus 4 by 3. So this is the velocity of the particle at that point. And since this is a greater than equal to 0, so we cannot take the negative value. So we will be we can take only positive value, right? So velocity can be positive, negative, no problem. X is not negative, so sorry, so velocity can be positive, negative, no problem. Okay, next question says, so that the equation of motion of a rocket in the absence of any external force is given by this. So where m and v are the interstellar mass and velocity of the rocket respectively, u is the velocity of the spent fuel relative to the rocket. So from the conservation of linear momentum, the mass into velocity total equal to this one, and this equals to 0. If you derivative these two part, you will be obtain easily this relation. I think there is a mistake. This equal sign is not needed here. It is multiplication. I think if there is any mismatch, you must comment. Next, the total energy of a particle moving in a central force field is the sum of its kinetic energy and the effective potential energy. Explains so the total energy is conserved. Actually, for that you need to know about the radial part of the force and cos radial part. So these two are expression, and if you just use this mathematical expression, you can easily find out this one, which is the potential. So total energy must be equals to constant. Next one, the trajectory of a particle of mass m moving under the influence of central force in a plane polar coordinate system, this one. So in plane polar coordinate system, the r equal to given here. You need to find out the and the angular momentum L is L and total energy is 0. Express the potential energy in terms of ml alpha. So you need to find out the potential energy in terms of this. So position vector is like that, and velocity equals to this one. So angular momentum L r cross v. So if you cross product, you will be obtain this one m r square theta dot, and there is a phi cap. So you need to say that there is a vector sign, right? So I just write down a vector sign here. Okay, clear. Okay, so this is the L linear momentum. So the magnitude will be m r square theta dot. Now the total energy as per question equals to 0. So potential energy will be like that. So put this value of v square is given here. You can see this is the value of v. If you want to find out the value, so this is square and root under alpha square plus 1 square. Okay, so if you put this value of theta dot, because you need to find out in the expression of ml and alpha. So if you put this one, you will be get the value of potential expression. Next question says, so that the kinetic energy of a system of particle is sum of total kinetic energy of the system of particle with respect to center of mass and kinetic energy of a particle of mass capital M, total mass of the system of the particle moving with the velocity same as the velocity of the center of mass. So the kinetic energy, simple. There is a ith particle. Okay, so kinetic energy how mi vi square summation is total sum of these all points. So this can be written as vi dot vi. So vi, that is the velocity of that point, is nothing but v of cm plus vi, because the position vector of this one equals to position vector of center of mass plus the separation. So if you take the time derivative, you will be obtain this relation. So just put this value of vi vector in this format. So if you dot product this one, you will be obtain this string. And you can see this is nothing but total mass, and there is the mass of this one, and there is a summation mi vi, because you know the summation of mi ri equals to 0, so this becomes 0, so only obtain you this equation. So this kinetic energy is the sum of these two part. One is says total mass into velocity of this center of mass point, and this is the particle kinetic energy with respect to center of mass. So the kinetic energy of this body is equals to two part. First one is the kinetic energy of this center of mass. Actually this is the kinetic energy of the center of mass, where the mass total constant concentrate, and the kinetic energy of this particle with respect to center of mass. Next question says two particles of masses m1 and m2 moving with relative velocity v, and velocity of their center of mass is vcm. If capital M is the total mass and mu is the reduced mass of the system, then prove that total kinetic energy is like that. So kinetic energy of mass m1 with respect to center of mass equals to like this, and for m2 mass this one, total kinetic energy will be like that. Now the kinetic energy of the system is minimum relative to the frame attached with the center of mass is tcm, called internal kinetic energy, and does not depend on the reference frame. So the total kinetic energy will be like that, this one plus total kinetic energy of this mass system and the center of mass velocity. So finally you will be obtain this relation. Next part says for a homogeneous cube of mass m, this is a homogeneous cube with mass m and the side is L, our principal axis or origin at center of the cube, determine the principal moments of inertia and set up equation of ellipsoid of inertia. Okay, so mass of q is m and length of side equals to L. So mass per unit volume equal to m by s. So the principal axis will be x, y and z axis. Principal moment of inertia will be this one. So taking the integration, you will be get this one. Similarly for y and z, we will do like that. So moment of principal moment of inertia are there, and the x, y, z, these are product of inertia. So you can write down this as a product of inertia. Principal moment of inertia is the ixx, iyy, izz, and these are the product of inertia. These are the product of inertia. This needs to inertia. This is required for the ellipsoid of the inertia. Okay. So you can see the product of inertia are all equal to 0, and in principal moment of inertia, the product of inertia actually 0. So the ellipsoidal equation will be like that, and we will be get this equation is the sphere, because these are the cube, so all are symmetry, that's why this becomes a spherical equation of sphere. Okay, I think clear. If there is any doubt, you must comment in the comment box. This is all about me, and this is my contact detail. You can connect with this Telegram channel, and this is my YouTube channel details. Go to this channel, you will get different physics videos and mathematics. Like this session, if you learn something for this session, share this video to your friends so that he or she also get benefit from this video. Subscribe the channel if you new in this channel. Those already subscribed, thanks for subscribing. Press the bell icon to get notification of upcoming. So take care. Take care. We'll meet in the next video as soon as possible. Thank you.